Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about question bank on a DC machine. So question bank questions we are going to discuss in this video lecture. So first question, here total we have 20 questions. So first question is state the working principle of DC generator. Explain the working of DC generator with neat diagram. So this is the diagram. So simple elementary model of DC generator. In this, in between two opposite pole, one single turn conductor is placed. Means what is the principle here? The Faraday's law of electromagnetic induction according to the dynamically induced EMF. According to the dynamically induced EMF means E is directly proportional to the d phi by dt. So there must be relative motion between single turn conductor and that magnetic field. So that induced EMF. So that induced EMF, there is a relative motion, then there is a induced EMF. That induced EMF is the, so here induced EMF, that is Faraday's law. Now here rotating conductor generator means which converts from mechanical energy to the electrical energy. Rotating conductor placed in a stationary magnetic field. So this is a rotating conductor placed in a stationary magnetic field. So induced EMF will be developed in the this single turn conductor, and if you connect the load, then current flows in this circuit. So this electrons always flows always opposite, electrons direction is always opposite to the flow of current. Now here rotating conductor, first take 0 degrees, theta equals to 0. This is at theta equals to 0 degrees and theta equals 45 degrees, theta equals to 90 degrees, theta equals to 135 degrees, theta equals to 180 degrees, and theta equals to 225 degrees, and theta equals to 225 and 270 degrees, theta equals to 315 sorry, and theta equals to 360 degrees. One complete one cycle, one sinusoidal waveform will be generated. So E is directly proportional to the d phi by dt. According to this one only, so EMF will be developed. This is at 90 degrees and this one at 180, 270 and next 360. So this question, this working principle of DC generator already we discussed in the previous lecture. That is the working principle of DC generator. So rotating conductor, so with this angle conductor, single turn conductor is rotating and induced EMF will be developed. So that we discussed in the previous lecture. So now next question, second question, write the equation for generated EMF in the DC generator. So E equals induced EMF equals Zn phi by 60 into P by A. So describe, so this is the, so EMF for generator, E is directly proportional to the d phi by dt, this one. So according to this one, so flux per pole, flux cutting for one conductor, so that is phi p, this one d phi, and next this one dt indicates this one n60, and next time taken for this one dt is 60 by n. This we discussed in the previous lecture, EMF equation of DC generator. Now here the final equation is E is directly proportional, E equals to Zn phi by 60 into P by A. Z is the number of conductors and n is the speed of the conductor in RPM, and phi is the flux per pole, and P is the number of poles, and A is the number of parallel paths. Now here describe various types of self-excited DC generators. So first one, so now here this is shunt generator, and this is a series generator. So if there is a connection between armature winding and field winding, that is the, there is a connection. If there is no connection, that is separately excited DC generator. Here they are connected in series. So this is series generator, and this one is the shunt generator, and next this is the compound generator. This one is also compound generator. Compound generators are classified into two types, long shunt and short shunt. This is long shunt and this one is a short shunt. So depending upon the connection, here we have two field windings, field winding 1 and field winding is 2. Here we have field winding 1 and field winding 2. So if in this one field winding is connected in series and other field winding is connected in parallel. Here is also one is connected in parallel and other one is connected in series. So in this way, field windings are connected with armature. So these are the total three types of self-excited DC generators: short DC generator, long series generator, shunt generator, and compound generator in that long shunt and short shunt DC generators. Next, classify types of DC generator, explain in details. So first, DC generators are classified into separately excited and self-excited. In the self-excited, as we discussed in the previous slide, so shunt wound, series wound, and compound wound, and the compound one again long shunt and short shunt. So these are the different types of DC generators. So that the individual circuits I already explained that classification of DC generator in the previous lecture. Just go watch that lecture, classification of DC generators. So now different types of losses here, various losses of DC generators. So here we have copper losses and iron losses and mechanical losses. Three types of losses total. So first in this, armature copper losses, shunt copper losses, and series copper losses. Three types of copper losses. So I square R losses. So now here iron losses means core losses. Core losses. So these core losses are hysteresis losses and eddy current losses. And next, mechanical losses means frictional losses and windage losses or air friction losses. So these are the different types of losses. So this slide, so I also explained in the previous lecture, that lecture name is efficiency of DC machine. So now just watch that lecture, you will get an idea. Next, what are the constructional parts present in the DC generator, and briefly explain about their functionality in the operation of DC generator. So this lecture also I explained. So just construction of DC machine. So in this, the main components, what are the main components? First here, yoke. So this one is a yoke, and yoke material used for yoke functions, yoke definition. And next, poles and pole winding, pole core and pole. So this is pole core and this one is a pole shoe, and this is the field winding, exciting winding. And next, armature, this one, rotating conductor placed in a stationary magnetic field, and there is a commutator and brushes. These are the brushes. This one is the commutator, and these are the armature conductors are placed in the slots of the armature core, and this is the terminal box. So each part we discussed in the previous lecture, construction of DC machine. So just watch that lecture. Material used for that each part. Next, explain the process of built up in the self-excited DC generator and state the condition for separately excitation. So here in the voltage build up in the self-excited, because of due to the residual magnetism, there may be a induced EMF in the armature winding. It uses that winding and it builds up the voltage build up. So now here in the separately excited, so this is the armature, and this one is this field winding is excited with other source, and this field winding which we give with other source, current flows in this circuit and it sets up the flux. This stationary flux cuts the armature conductor and induced EMF will be developed in this. But in case of this self-excited, there is a because of residual magnetism. This is the field winding. So because of that residual magnetism, so that flux cuts the armature conductor and induced EMF will be developed in the armature conductor. So that is the self-excited voltage build-up process. Next, classify and describe different types of characteristics of DC shunt generator. So what are the characteristics of DC generator? So first, open circuit characteristics, first one. So also known as the magnetization characteristics or no load characteristics. So second one, load characteristics, in that internal and external. So these are induced EMF versus and field current, and in this internal means EG versus IA and V versus and IL, load voltage versus load current, and induced voltage versus armature current, and induced EMF, induced voltage versus field winding. So if you draw the graph between these, this is the series generator, this is IF and this is the IEG. So now because of residual magnetism, it starts from here. This is the open circuit characteristics. Or magnetization characteristics or no load characteristics. There is no load. If you connect the load and current flows here, so now here shunt generator. So shunt, this is open circuit characteristics are same for all generators. Now here for series generators, here next for series generators, this is for OCC and this is for internal, and this one is for external. Interpret the constructional features of DC machine with the help of neat diagram. So same diagram. So this one constructional details. So this I explained in the previous lecture, construction of DC machine. In the previous slide also, second question, third question I think. So that one is also same. So these are these parts I explained the previous lecture. Just watch that lecture. So the working principle of DC motor. The working principle of DC motor is very simple. So it works on the principle of Lorentz force law and Fleming's left hand rule. In that, so current carrying conductor placed in a stationary magnetic field, it experiences a mechanical force towards a particular direction. So the direction can be determined by Fleming's left hand rule. So now here one single let us take one simple elementary model of DC motor. In this model, so in between two opposite poles, one singleton conductor is placed. That poles are north pole and south pole. Now here, so this current carrying conductor, if you give supply to this one, current flows in this, current flows and current flows like this, current flows and current flows and current flows like this. So this is current carrying conductors. It acts as an electromagnet, and this is the permanent magnet, stationary magnetic field. So because of the interaction of these two fluxes, there may be a force. So that this lecture also explained the working principle of DC motor. Current carrying conductor placed in a stationary magnetic field, and it experiences the mechanical force. So for that case, if you apply Fleming's left hand rule, so now in that case, this is flux direction. So middle finger direction is flux direction, and this one is the current direction, and this one is this here is upward direction, here is the downward direction. So now after clockwise rotation of 90 degrees and it comes to the vertical position, there is no force, and because of moment of inertia, it comes to the horizontal position. Again apply Fleming's left hand rule, and it is upward, and whichever conductor comes under north pole will get upward mechanical force, whichever conductor comes under south pole and will get the downwards mechanical force. So due to these upward and downward mechanical forces, one torque will be generated. So the torque is known as the mechanical energy. In this way, mechanical energy will be developed from electrical energy. Next, derive the torque equation. This question is also we discussed in the previous lecture, the torque equation of DC motor. So first Mechanical power developed on the shaft equals to IA into EB, this one. And next, that one equals to PM equals to omega T. Omega means 2 pi N and T is a torque, and this T equals EB by 2 pi N if you if these two are okay. Next, EB equals Z N 5 by 60 into P by A. So if you substitute in this in case of EB, and there is NN gets cancelled, and this one, so torque equals to 1 by 2 pi Z 5 pi IA into P by A, that equals to 1 by 2 pi means that one is 0.159. So the final equation for this one equals to T equals to 0.159 Z into I into IA into P by A. So this is the torque equation of DC motor. So this derivation is important. Next, describe the different types of motors with equivalent circuits. So different types of motors means motors also classified into two types: separately excited and self-excited. In the self-excited, again three types. So long shunt, shunt wound, series wound, and compound wound. In the compound wound, again classified into long shunt and short shunt. Next, so the diagrams also we discussed in the previous lecture. The classification of DC motor we discussed. Watch that lecture. Next, explain the different characteristics of DC motors with neat diagrams. So now here, so what are the different characteristics? So first here, so speed, torque, current characteristics. So this is torque and current. So T equals to 0.159. So Z phi IA, Z phi IA into P by A. So T is directly proportional to the IA for DC generator. So T is directly proportional to this one. So now torque slip for series motor. So this diagram should be like this. And next, torque speed characteristics. Torque speed characteristics means, so this is the torque and speed, and this one is the torque and speed for series. This is for shunt and this is for series. So for this case, this is the diagram for torque speed characteristics. For this case, this is the diagram, rectangular hyperbola. This is the straight line. Here straight line passing through the origin, here the parabola. So torque speed and torque and armature current. So now next case, explain the applications of DC series motor, shunt motor. These are the different applications. So for constant speed applications, for medium torque, constant speed and medium torque, we will use these shunt motors. So for the case, for lathe machines, centrifugal pumps, reciprocating pumps, blowers, fans, drilling machines, milling machines, and machine tools, we will use series motors. And next, for series motors, we will use for high starting torque, means variable speed. So these points are important. And next here, conveyors, hoist, elevators, cranes, and electric locomotives. So for this case, we will use series motors. Next, starting torque. So here, compound motors we will use here for shades, heavy planers, rolling machines, and elevators. So we will use this one. Next, state the factors that affect the speed of the motors. So what are the factors which affect the speed of the motor? So E equals to Z N 5 by 60 into P by A. So here induced EMF and flux are these two are the main methods. So these induced EMF and stationary flux. So these are the main effects for the effect of speed of the motor. So N equals to EB by 5 by n equals to n is directly proportional to the EB by 5. These two are. So this is the flux control method and this one is the armature control method. Describe the different types of losses that occur in the DC motor. So same thing. So three losses: copper losses, iron losses, and mechanical losses. In the armature copper losses in this, and this one is a shunt copper losses and series copper losses. These are the I square R losses. And next, hysteresis losses and eddy current losses, PH and PC. So to reduce the eddy current losses, we will use laminated core, and to reduce the hysteresis losses, we will use high grade silicon steel material. And these are the frictional losses and these are the windage losses, that means air friction losses. This I explained in the previous lecture. Next, list the describe the different parts of DC machine, how the commutator and brushes deliver voltage to the. So these are the parts. Same, the construction of DC generator we discussed. So next, explain how commutator and brushes deliver voltage to the armature. So first, here DC voltage. If you give DC voltage to armature, so if you give DC voltage in case of DC motor armature, so it gives through the brushes and commutator. So now here brushes. So from the stationary alternating stationary voltage to the rotating voltage, and so here commutator and brushes are given to the armature. Next, discuss and differentiate DC motor and shunt motor and compound motor. So now, so depending upon the connection only. So this one is the armature. This is a supply V, and if it is a field winding, and this one is the armature, this is the supply. So field winding and armature winding is connected in series. Series is this one, and if it is parallel, this one. If two field winding, this one field winding, other field winding connected in series, two field winding. This is the compound generator, and different applications and different equations. So armature EG equation for each one, and IA and field current and field current, and applications for each. So these are the main difference for three motors: series, shunt, and compound motor. Next, 18th question. Explain the back EMF. Explain the back EMF in DC motor. So back EMF. So the counter EMF developed in the armature of the DC motor is known as the back EMF. So the importance of back EMF in the DC machine, I already explained in the working principle of DC motor. In that, when here this is the DC, this is the north pole, and this one is the south pole. So when kite is, it carries the current and induced this mechanical energy will be developed on this armature core, and it rotates. And when it is rotating means, and counter rotating conductor placed in a stationary magnetic field, here counter EMF will be developed, that is known as the EB. So that importance I also explain in the working principle of DC motor. Now here, with the help of neat sketches, so explain the torque speed characteristics of DC series and DC shunt generator. So this is the shunt generator, torque and speed characteristic. This is for series generator. torque and speed. Sorry. This is for shunt. Next, the last question. Describe the relation between speed, torque and horsepower. So that relation is horsepower equals to torque into that RPM, that speed divided by 5 to 5 2. So this formula. So power equals to torque into speed. This is the formula, but in horsepower, so torque into RPM divided by 5 to 5 to this one. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.